got one of the mag crankcase halves ready for assembly on the engine stand at the moment, and there's two or three things on here that I just want to talk about because they're quite interesting, and Nick will take us in. So what you were talking earlier on, Nick, about the way the whole case can creep.
Yeah, a lot of people just do standard engine rebuilds on these things. The problem with the magnesium is, over the years, it tends to wander all over the place. So what we do is we lock the two case halves together. Now this is a modification which they used to use in the race engines, because under high RPM the cases would chatter, so they would lock them together. Now we use it for slightly different reasons. Because of the age of these cases now, they sort of tend to wander around. So what we do is we lock them together with the pins. So obviously on the other side here we've got the holes, and it basically just locks your main journals together. And then we realign it by line honing it. That's a big honing mandrel that's parallel, and basically it just takes out all the high spots so you can actually get it all lined up properly. Now you can see this example here where this is actually honed at this stage there, which meant this journal has just shifted down this way slightly, because you can see it hasn't actually kissed it there. We hone these back to standard sizes, because what usually happens is they splay slightly, which means on a lot of magnesium cases, if you actually measure them up, they will splay along the split line of the crankcase and contract along the thrust faces, which sounds a bit strange, considering all the forces are going through the thrust faces. So you've got the piston based obviously this side forcing against this side, and then vice versa on the other case you've got the forces going through to the other side of the case, which, like I say, does sound a bit strange, but it does actually contract across there. Now you usually find these are undersize manufacturers' tolerances, so luckily for us, when we hone them out, it basically just takes them back out to standard sizes. A few cases we've come across where we've had to go 0.25, but we're always reluctant to do that, just in case the engine has a trauma in later life and the case is scrap, because you can't go beyond 0.25 because the bearings aren't available. So we err on the side of caution. Obviously inspect all the parts, make sure everything's, you've got a good, still a reasonable seal around the back of the bearing, supply the oil into the main bearings. But yeah, that's one of the main things which we do. We always recommend everybody has that done, to be honest with you, and if people don't want that having done, generally speaking, we don't entertain the job, because it's a case of doing the job properly, as we regard it. Another small mod on the case is, which they did on the later, this came in about 1975, 76, around that era, was the pressure relief bypass. Now, when the oil pressure builds up certain pressure, there's a valve and a spring that opens, and there's a bypass. What happens on the early cases is, if we get a torch, you can see down there, there's a hole down there. Now that's open on the early cases. So what happens is, when that pressure relief valve opens, it dumps all the excess oil pressure straight into your crankcase, which means your scavenge pump's got to work a little bit harder because there's more oil going into the case. What they did on the later cases, from sort of 75 onwards, even the mag case engines, was they put a drilling down inside that journal, that all the way down there, and the casting was just left blank there. So what we do is we pull the bung out of the outside of the case, we drill that hole in there, blow it all through, clean it after reaming all the way through there, and then we put a little aluminium bung in there, it's just down on that part there, to plug that end, and then re-plug the case. And what that does is, that basically, this is the oil pump feed. So what it does is, as the oil pressure relief valve blows the oil pressure off, it just returns it straight into the pump feed. So it doesn't, so it just doesn't make the scavenge pump do so much work. That's quite an important mod as well, which we do on these cases.
Okay, and we're going to talk about the oil pump mod shortly.
That's right. Yeah. A few other little bits and pieces on the case before we start building it up, which we do, it's compulsory, which we do. We always machine the barrel decks. So that's your foundation to the whole build. If those surfaces aren't level, that'll affect your cylinder height, your cylinder head height, and then it'll affect your cam carrier height as well. Your they hold your rockers and your cam, so they could distort that. So we always take a datum off there, and we have a set distance. We know what a standard size is, and then we reface exactly the same both sides, so they're equal. So you have a level foundation to start with. Now, in my experience, I've only ever come across one case that's never needed doing, and generally speaking, you'll have to remove up to 10 thou off of a barrel deck to actually true it up.
Yeah.
And what happens is you'll find it'll sag around those parts there, or around the lower parts.
The lower parts, yeah.
As we were discussing this earlier, I've done a museum car before with an engine which hadn't been really run or worked hard, and that was a brand new case they built this into, and even that had sagged. And I think it is just the weight, all that weight. Just
barrels and pistons,
it's just physically, just over the years, it'll just physically, just gently, just ease it down. So it's one of those jobs. You can't. I'm a believer of the fact you can't do a top end rebuild on one of these without doing that. So unfortunately, you have to have the whole engine apart, and if you have the whole engine apart, you have to have the whole thing done. If you do have a top end rebuild done on one of these, and you don't have that done, you'll end up with oil leaks or a tight engine build and potential failure in the not too distant future.
And that applies to the aluminium and the mag?
No, that's just a magnesium
the mags,
case,
yeah,
because
okay.
the alley cases are bulletproof. They're so strong. The material is a different material. The magnesium is a very unstable material. But yeah, that's a process which we do, and every engine that we build physically, we do all that sort of work too. Another mod which we've done here is fit the time certs, which is just drill out the original threads, and then put a steel insert in there, which gives you more surface area and more strength to physically pull into the magnesium instead of the M10. It goes out to an M12, and then it's got an M10 hole in the centre. Once again, magnesium case engines, guaranteed you've got to do it, because they, generally speaking, pull the threads out of the magnesium. Yeah. So that's, generally speaking, that's sort of what we do on the engine cases. That's just a set procedure which we use. Yeah.
I mean, there was one other, while we're on the crankcase halves, there was one other repair you had to do on the other crankcase half, which was the
oh, that's right, yes. Yeah.
Pipe.
That's, if you recall from the previous photographs where we filmed it, the scavenge pipe union had been broken off previously. So what we've done is we've machined the case down. Luckily for us, there was enough meat in the casing itself, in the casting, to actually drill it down further and tap a thread into it. And then we've modified a union, oil feed union, and made a spacer up so we can get the throw on it correctly, and made a threaded tube up, and that'll just tighten back up with aluminium washers either side, a little bit of sealer, and that's a job done. We're finding a lot of engine cases now need these sort of repairs, because over the years they've been messed around with, damaged, and because we get a lot of engines which are sort of numbers match engine to cars, it's viable to actually repair the cases.
You can't afford to throw them away. Yeah.
No, that's right. So and especially things like genuine RSs and RSRs, if it's a proper numbers match car, the value is so much higher. It's worth spending the money to actually resurrect the case.
I've got everything laid out now on the bench, ready for assembly, and Nick's obviously gone to a great deal of trouble to make sure he's got everything he needs for the build, and this is something which you need to set aside a good amount of time without interruption, so that you can get stuck into the job and get it largely done to a stage where you can leave it. But the first thing we're going to talk about is oil pumps, because one of the things that we're putting into this car is a later oil pump, and Nick, you've got both types there.
Yes, well, this is the early magnesium type, which is out of a 2-litre engine. These, generally speaking, wear a bit more because they're magnesium. I mean, a good sort of rule of thumb, if you strip your pump down, you'll see that where the two rotors meet, you've got a little groove there, which is just a machining process, basically take the burrs off. But what it enables you to do is, if you look inside the case, you can actually feel where the rotors don't touch. If you have a a lip there. Because obviously if there's a parallel rotor and there's no join, it would be very difficult to sort of measure that and say, yes, that's out of tolerance, that's not going to be any good. And the last thing you need to do is obviously build up an engine with a bad pump in it, because you're just going to end up with low oil pressure.
Yeah.
Now, obviously this one you can just feel, I don't know if you can see that, that's a white mark there around there, which is an untouched part of the bore of the pump. And that's basically where the V is on those two rotors, where they join. And if you run your finger across that, you can actually feel there is a step there, which means the pump is worn.
Ah.
So if we had to put this back in, we would be having sort of low oil pressure problems, which particularly stands out at tick over, because the needle will just drop off the gauge. You'd probably be able to sort of get the pump up, but this is the scavenge side of the pump anyway, so it wouldn't be scavenging correctly.
Right.
You've got two stages, so you've got your scavenge on this side and then your pump on this side. Now obviously your scavenge is a much larger surface area than your pump, because you want to suck all the oil out of the crankcase, whereas the pump is just there to put the pressure in, and that just goes off to your main bearings and then big end bearings and intermediate shaft and cylinder heads. So checking the scavenge out is quite important. If your scavenge isn't working properly, you'll notice this when the car's ticking over, where it's not been able to scavenge the oil out of the crankcase correctly, and you get random readings on the oil tank on your level gauge.
Yeah.
And it just doesn't make any sense when you're sort of trying to check the oil level on the cars, basically, because it's not giving you an accurate level in the tank, because it's not physically drawing it out. So in this circumstance, we're going to have to change the pump. Now, I mean, there are different pumps all the way through the range. They use quite a big, the early 2 litre pumps, they went actually down, they changed down on sizes a year or two later, and then they went back to basically the same size scavenge and pressure side. And then you've got your turbo pumps, which are obviously, they use a lot larger scavenge and a lot larger pressure, and then the 964 it's just evolved and evolved.
Yeah.
So your pumps are, the problem is now these days, I think last time I went to buy a pump, the only pump that was available now is a 964 pump. The issue is you've got to modify your casing slightly to get them in. Now, I'm not saying that sometimes they go in and out of production. At that stage, that was all that was available. You might find now that you can get the 3.2 pump again, which was the upgrade for all the pumps. You couldn't get hold of SC pumps anymore, or early pumps. Basically, they just superseded part number to a 3.2 pump. Right. Which is a perfectly adequate pump. I've got 3.2 pumps running in race engines. A lot of people sort of say, oh, they want to stick a turbo pump in there, but for the weight of the pump and the extra scavenge and pressure, it's just not necessary really, because the higher pressure side on a turbo pump is just pumping more oil away that needs to be scavenged anyway. So I said I've got 3.2 pumps in race engines, and I've never had an issue with oil pressure and bottom end failures. So
what we've got here is a used SC pump.
That's it, yes.
And what's the main advantage of that over the original 68 pump?
Part of the fact it's not worn.
That's okay.
Yeah, I think they last longer. To be honest with you, SC pumps, I've very rarely come across a worn SC pump. It's squeeze cast aluminium. The casings are a lot stronger. The rotors are exactly the same internally anyway.
Right.
And you just find that you strip an SC down, and the last thing that needs replacing is a pump.
Yeah.
The bottom ends are always good on them.
So you're basically going to get more consistent oil pressure.
Yeah, that's right. Yeah. That'll just last longer. It's just a good route to do, really.